The ICEVI, the Nippon Foundation Mathematics Package for Teachers. Title of the video, all about triangles. Let us take this triangle A, B and C. Now AB is a side, AC is a side and BC is a side. Similarly, we have angle A, angle B and angle C. Now what is special about this triangle? Now let us take the side BC. Now you measure the side BC. Now you measure the side AC and then you measure the side AB. All are equal. So in this triangle we have all the sides having equal length. Now we have formed an angle A. Now you just take that and measure B and then also measure C. So that means all the three angles in this triangle are of same measurement. So in this triangle the three sides are equal and the three angles are also equal. You call this triangle as equilateral triangle. Take the next triangle. So here again you call that as A, B and C. Now what is the difference between the earlier triangle and the current triangle? You measure AC and measure AB, which are equal, but they are different from the side BC. So what happens in this triangle? There are two sides equal and one side is not equal to the other two sides. Again you measure the angle. Now angle B is same as angle C, whereas it is different from angle A. So in this triangle there are two sides equal. So you call this triangle as isosceles triangle. Now let us take this triangle. Now here let us call this as A, B, C. Now you measure AC. Now AC you measure, which is not equal to AB, which is not equal to BC. So that means here the three sides are not equal. That means no two sides are equal. So every side is different. So you call this triangle as scalene triangle. Now let us take the angles. In the case of the first triangle, we notice that all these three angles are less than 90 degrees. Take a paper strip which has a right angle. Now you can notice that this angle is not 90 degrees. Similarly, the other angle C is not 90 degrees. Angle B is also not 90 degrees. That means angle A, angle B and angle C all are less than 90 degrees. So we call this triangle acute angle triangle. Now let us make the equilateral triangle into two halves. So you make them into two triangles. So what we get here, suppose we call A, B, C. What happens? You look at one of the angles of this triangle B. This is a right angle. This is a right angle. So you call this as a right angle triangle. Now you measure the sides. No two sides are equal. No two sides are equal. That means the three sides of the triangle are not equal, so you can call this as scalene triangle also. At the same time, you take the other scalene triangle where the three sides are not equal. But what is the difference between the right angle triangle in which the three sides are not equal and the current triangle where the three sides are not equal? You can notice in the right angle triangle, angle B is 90 degrees. Now here you take angle, one of the angles, it is more than 90 degrees. So in this scalene triangle, one of the angles is more than 90 degrees. So you call this triangle as obtuse angle triangle. Now let us take this small triangle. We notice that this small triangle is similar to the equilateral triangle that we have. Let us take the ABC, equilateral triangle. Now we have a small triangle. Let us call that as A1, B1, C1. Here what happens? The A1, B1, C1 triangle is similar to the triangle ABC. Why? The side of the small triangle is proportionate to corresponding side of the big triangle. Let us make a measurement of this. Okay, so you take it to the big triangle, 1 and approximately 2. Similarly, take the side BC, you can notice that it is approximately 2. Similarly, take AC, it is approximately 2 times. The sides of the small triangle are proportionate to the sides of the big triangle. So you call this as similar triangle. One thing you have to note is, in similar triangle, the angles are same. For example, angle A1 is same as angle A. Similarly, angle B1 is same as angle B. Similarly, angle C1 is same as angle C. However, the sides are not equal, but they are proportionate. And these triangles are called as similar triangles. You also use another terminology as equiangular. For example, you take this scalene triangle. Now, let us label C1, A1 and B1. Now, you can notice that C1 is equal to C, A1 is equal to A, and B1 is equal to B. So that means, the angles of the two triangles, if they are equal, then you call that as equiangular triangles. You can notice that equiangular triangles are also similar triangles. One more property of the triangle is also to be noticed. The two sides of the triangle, when they are put together, they will be definitely greater than the third side. In this video, we have demonstrated the different types of triangles and their properties.